Now we will go in detail what is fuzzy inference. So fuzzy inference is a process of mapping from a given input to an output using the theory of fuzzy set, and this fuzzy inference will involve 4 steps of process. Okay, one would be fuzzification of the input variable. The second one is the rule evaluation using arithmetic operation. And then we are going to have the aggregation of the rule output here. And last but not least, we are going to do the defuzzification. First, let us take a look at fuzzification process. What is fuzzification? Fuzzification means converting the crease input to fuzzy input. Okay, so in here we have crease input. For example, our crease input is x equal to something. For example, we have x is equal to 15. X represent a variable here. Okay, so you are going to find the fuzzy input that would be y. Okay, so what would be the y, or the degree of membership those degree of membership will be range from 0 to 1, right? And we are going to use y equal to mx plus c equation so that we can find this y here, this particular y. So we are given this x, we are going to find this y. Okay, so this is the process, this is what we call as the fuzzification process. This is a further example of it, a further explanation. So we take a crease input x1. Okay, so for example, we have x1 is equal to 35. We are going to find the intersection of the graph, okay, in the fuzzy set, intersection between x1 and our graph here. So we have 3 graphs here, a1, a2, and a3. We are going to find the intersection for each of it, okay. Then we are going to identify the degree of membership. Okay, say we have x1 here is 35. It should be around here. Okay, so let us take a look. Where is the intersection of x1 here with a1? Okay, it will be somewhere around here, right? And this one will go to the degree of membership that we have here, 0.5. Sometimes, most of the time in your final exam, you are going to use y equal to mx plus c equation. Based on this graph here, you are going to find this degree of membership. Okay, so we have here degree of membership x equal to, x that intersect a1 would be 0.5, and then another one we are going to find the intersection with a2. It will be somewhere around here, that is 0.2. Let us discuss where would be the intersection of our x equal to 35 to a3. Okay, is there any intersection? Okay, yes, there is an intersection. Okay, where the intersection is at 0, because if you take a look at a3 here, the graph is actually like this. Okay, it is like this. The range is still from 0 up till a value here. Okay, but then from 0 to this particular value here, this particular x value here, the value of the the value of the graph is somewhere around 0. So that is why the degree of membership, if x is equal to a3, or if x intersect a3, it will be 0. Okay, so this is for one variable. Okay, one variable meaning that from the rule one antecedent, and then this is from another antecedent of our rule. Okay, antecedent 1, this is antecedent 1 and antecedent 2. We are going to find the output. If you still remember our rule here, okay,
Now,
so we know that the first one is the first antecedent, the second one is the second antecedent, and the third, or the then, okay, the then value there is the output, right? Okay, so the example here is the first step is the crease input x1 and y1. So our X1 here is the project funding and our Y1 here is the project staffing. Please, please don't get confused. Y1 here does not represent those degree of membership. I mean, those Y-axis. It actually represent the variable. I mean, the value of trace value, okay, for the second variable, okay. So X1 will represent the project funding, Y1 will represent project staffing. So from there, we say that X1, okay, X1 is for the project funding. So this is the graph of project funding, okay. B is for project staffing. So we are going to implement the Y1 value into the project staffing graph here, okay. So we have Y1 is equal to 60 here, okay. Y1 is equal to 60. So let us take a look where is the intersection, okay. At B1 it will be intersect around here, at B2 it will be intersection around here, right? So we have to find those degree of membership. Say we have B1, degree of membership of B1 is 0.1, degree of membership of B2 is 0.7. So from there, after we have done those fuzzification process, we know that we have obtained the fuzzy input here. Okay, so these are the fuzzy input using the fuzzification process. Always remember the fuzzy input would be the degree of membership range from 0 to 1, okay. See, the second step or the second process is to take the fuzzify input and we are going to do the rule evaluation, okay. So from here, our fuzzify input, we have 4 fuzzify input. A1 is 0.5, A2 0.2, B1 and B2 0.1 and 0.7 respectively, okay. We are going to apply them to the antecedent of the fuzzy rule, okay. So based on our fuzzy rule, okay, we are going to put this value to our antecedent, okay. So if a given fuzzy rule has multiple antecedent, okay, so we have multiple antecedent that is being bounded by N or O, okay, by fuzzy operator, we are going to obtain a single number that represent the result of the antecedent evaluation, okay. Using this N or O operator, we are going to obtain our single number. So this number, the truth value, is then applied to the consequent of membership function. Let us take a look what is it talking about, okay. So do you still do you still remember our rule just now? So this is our rule 1, okay, rule 2 and rule 3 here, right? So rule 1 is project funding A3, okay, project funding A2 and project funding A3, okay. A3 represent adequate, marginal and also inadequate, okay. And our project staffing B1 here is for small, B2 is for large, okay. So if we still remember, what is this? These are the value that we have obtained from the fuzzification process, okay. So for example, in A3 we have obtained 0, right? 0 here, okay. A3 we have obtained 0. And what about A2 here? A2 we have obtained 0.2, okay. B1 we have obtained 0.1, B2 we have obtained 0.7, okay, and A1 we have obtained 0.5. So all of this will be written in our rule, okay. So next we are going to find the fuzzy, we have here multiple antecedent, right? And we are being bounded, these rule are being bounded by N or O, right? We are going to find a single number from this. We know that, okay, we have 0 and 0.1 here. We have 0.2 and 0.7 here. So which value here are we going to give to the consequence here, okay? So we are going to do, we are going to get the single value by using our fuzzy operator and the rule evaluation. So how are we going to do this rule evaluation? First, we have to evaluate the disjunction of the rule antecedent. Okay, if we have the disjunction or conjunction, okay, we need to determine it. Okay, if we use the or fuzzy operation, okay, we are going to have a maximum value. Okay, so this is the maximum value. So from here, if we take a look at here, so we have here or, right? So from these two, from this multiple antecedent, we are going to take the maximum value since we are using or in this rule. Okay, so out of these two, what is the maximum value? 0.1. Okay, if we have conjunction, okay, conjunction meaning that we apply an fuzzy operation, so we need to use the minimum value. We need to find the minimum value. So we have here in rule 2, we have n fuzzy rule here. Okay, so from these two fuzzy input 0.2 and 0.7, what would be the minimum value? Minimum value is 0.2. So this will be 0.2, right? Okay, so what about this one? This one, this rule has single antecedent. So you don't have to do anything since if we want a single number, we already get the 0.5 here. Okay. So from there, what you are going to do is, okay, you are going to get the rule evaluation by plotting, okay, plotting the graph that respective to the value of x and y, okay, based on your rule. So from here, you know that for the first rule, okay, it will intersect with A3, right? It will intersect with A3, that is adequate, okay, and then for y or for b, for project staffing, it will intersect with B1, okay, then it will get Z here, that is C1. So we need to what they call that, we need to find, we need to draw, we need to sketch back our graph here. Okay, so let us take a look. I will draw this one by one for you. Okay,